Fall officially arrived Monday afternoon, marking yet another astronomical milestone in Earth's annual journey around the sun. And though I suspect you have a general sense of what happens on the autumnal equinox, I thought I'd take a closer look. Now, because the Earth is tilted on its axis, the northern and southern hemispheres almost always receive different amounts of sunlight. But on the spring and fall equinoxes, the plane passing through the equator lines up with the direct rays of the sun, so neither hemisphere has an edge. And so at a specific time on those days, the sun is overhead at the equator. This happened this past Monday at 2:19 p.m. Eastern Time. The sun was directly overhead at a point in the eastern Pacific Ocean about 1,000 miles off the coast of Ecuador. Here's a satellite image from the first day of fall. The yellow line is the equator. The dashed white line is the so-called terminator. It separates the day and night sides of the Earth. Notice that on the autumnal equinox, the terminator parallels a longitude line, so each hemisphere is equally lit. Now here's the same view, but on the first day of Northern Hemisphere summer, June 21st. Here the Northern Hemisphere is clearly getting more sunshine. And finally, here's that view, but on the first day of our winter, last December 21st. Now the terminator is sloped the other way with respect to the equator, so more of the Southern Hemisphere is bathed in sunlight. Now back to the equinoxes, when Mother Nature provides us with a built-in compass, a way to find east and west on the horizon, because the sun truly does rise due east and set due west on the first day of spring and the first day of autumn. On and around those days, for example in Washington, D.C., where the National Mall runs east to west, the rising sun directly illuminates the statue in the Lincoln Memorial, bathing Abe in a golden hue as long as the weather cooperates. Now, the word equinox means equal night in Latin. The idea is that on the equinoxes, there's 12 hours of both daylight and darkness. But the sunrise and sunset table for this month in central Pennsylvania shows that's not the case. The sun will rise and set 12 hours apart tomorrow, 3 days after the equinox. There's two reasons for this. First, when sunlight passes through the atmosphere, it bends. So even when the sun is just below the horizon, it will appear slightly above the horizon because we see in straight lines, despite the curved path of light. The second reason involves how we classify sunrise and sunset. The sun is a disk, not a point. Sunrise and sunset are defined by when the upper portion of the disk appears and disappears, not the center. Together, these factors add a few minutes of daylight, so the calendar date, when day and night are equal, occurs after the equinox. One other important equinox-related number, in most of Pennsylvania right now, we're losing daylight at about 2.5 minutes per day, the maximum rate of any time of the year. Stay tuned. We'll be back in a moment with a recap of the forecast.